बहुत ही हर्ष का विषय है कि हम जिस यात्रा को लेकर चले थे, लगभग 22 अगस्त 2022 को हमने शुरू की थी एक कार्यशाला, 7 दिवसीय कार्यशाला, जिसमें अंतर्राष्ट्रीय स्तर पर भी बहुत सारे स्पीकर्स हमारे साथ जुड़े थे। जेम्स ग्लोवर, स्वाति दवे, ऐसे और भी बहुत सारे नाम हैं, विजेश कंबुल्जा जी जो कनाडा से हमारे साथ में जुड़े थे। उस यात्रा को हमने कहा था कि जब हम 28 अगस्त को उसका समापन कर रहे थे कि इस यात्रा को हम आगे भी चलाते रहेंगे। और मुझे बहुत ही हर्ष हो रहा है बताते हुए कि उस यात्रा का दूसरा पड़ाव आज फिर से हम यहाँ पे स्टार्ट कर रहे हैं, जो न्यू डायमेंशंस इन वैदिक मैथमेटिक्स के नाम से शुरू हो रहा है। इस 2 दिवसीय कार्यशाला में जो हमने जितने भी आयाम उसके ढूंढे थे, उन्हीं आयामों को आगे बढ़ाते हुए उसी के नए स्तर को, उसकी बारीकियों को ढूंढते हुए उस कार्यशाला का प्रारंभ किया जा रहा है। और साथ ही साथ हमारे बीच में जो हमारे स्पीकर हैं, मोस्ट इमिनेंट स्पीकर श्रीराम चौथाईवाले सर जुड़े हुए हैं। मैं सर से आग्रह करूंगी कि सर आप अपना जो मुख्य वक्तव्य है उसको आप प्रस्तुत करें, और हमारे जो जितने भी पार्टिसिपेंट्स यहाँ पर जुड़े हुए हैं ऑनलाइन और ऑफलाइन, मैं आपको बता दूं सभी की जानकारी के लिए कि हमारे लगभग ऑनलाइन पार्टिसिपेंट 70 के करीब जुड़े हुए हैं और ऑफलाइन भी लगभग इतने ही हैं। तो बहुत सारे लोग आपका बहुत देर से इंतजार कर रहे हैं कि सर जो आपका वक्तव्य होगा उसको सुनने के लिए बैठे हुए हैं। इस सेशन के लिए आपको जानकारी दूं कि इस सेशन को चेयर करने के लिए हमारे बीच में है गौरव चंदा जी। तो मैं आमंत्रित करती हूँ कि वो इस सेशन को चेयर करें, बैठें। उनके लिए मैं बता देती हूँ, he is a writer of most viewed writer on Quora for Vedic mathematics. He is a certified author and trainer for Vedic mathematics, awarded as best education and teaching best author for book authoring in Vedic mathematics at India, director of Vedic mathematics at Madhav University, Rajasthan, working with Kathmandu University to launch a certificate program in Vedic mathematics in Nepal. Now he is taking Vedic mathematics sessions for teachers under Directorate of Secondary Education, Haryana also. So, sir, most welcome in the department of CCS University. Thank you for coming. तो मेरा आग्रह है श्री राम चौथाई वाले सर से कि सर आप अनुग्रहित करें हमें, जो आपने पहले कुछ चीजें बताई थी। आज सर का टॉपिक है कापरेकर डिस्कवरीज, तो इससे आज हमें कुछ बहुत सारी चीजें जानने को मिलेंगी, सीखने को मिलेंगी। तो आप प्लीज स्टार्ट करें अपना लेक्चर। धन्यवाद सर।
सभी को नमस्कार, प्रणाम टू ऑल। Especially I'm observing the list of participants joined online at least. They include one of the most prestigious person named ShriRam Chauthaiwale, who is my uncle, 80 plus years, and गत 60 वर्षों से वो आसाम में संघ के प्रचारक है। प्रचारक निकलने के पूर्व उन्होंने MSc स्टैटिस्टिक्स किया था 60s में, और आज भी गणित और वैदिक गणित के प्रति अपनी आस्था रखते हैं। जब मैंने उनको सूचना दी कि ऐसा एक कार्यक्रम है, वो आज ऑनलाइन ज्वाइन हुए हैं कार्यक्रम में। मैं सबसे पहले उनको प्रणाम करते हुए मेरा वक्तव्य प्रारंभ करता हूँ। आज के इस कार्यक्रम में those are joined already, Dr. शिवराज सर, ऑनरेबल हेड ऑफ द डिपार्टमेंट, आज के सेशन के चेयरमैन, जो बहुत ही गणमान्य व्यक्ति है। मैं उनके प्रति भी अपना आभार व्यक्त करता हूं कि वो इस सेशन में चेयर के रूप में उपस्थित है, तथा सभी पार्टिसिपेंट्स joined online, offline. I could see many, Dr. Padmaja, Devraj, Dr. Rajesh Thakur, and many more. It is not possible for me to take all the names who have joined, Dr. Handa Madam, etc. So I begin my talk by sharing the screen now. Please allow me that way.
Yes, sir. It is visible.
Yes, that's fine. Ready?
Yes, sir.
Thank you. So I begin by saluting the great mathematicians of India, Dr. ShriRam Chauthaiwale. Many of you might not be knowing even the name, forget about his discoveries. But still, I will try to round up his work within the given time. So Ramchandra Kaprekar, born in 1905, so not much old one. He's 19th century mathematician in Dahanu, near Mumbai. Studied in Pune, and while studying in postgraduate, he has presented a huge paper on theory of envelopes, 93-page paper. That may be the academic record. 93-page research, first paper, 93-page research paper on theory of envelopes. And this particular paper immediately brought him in focus of the mathematics world, and he was awarded an honorary membership of Indian Mathematical Society, followed by many other honors. From 1938 to 1985, he regularly presented research papers. So for nearly 47 years, he used to attend Indian Mathematical Society conference, and in every conference, he used to present his research paper. Surprisingly to all of you might be, actually he was working as a school teacher near Nasik, Deolali Sainik School as it is called. So even being a school teacher by profession, he was a very eminent mathematician of India and presented, as I am saying, nearly 50 research papers and so many other works. Finally, University Grant Commission honored him as a national teacher in mathematics. He died in 1986. So with this short biography of his prestigious career, I switch over to his discoveries. There are many disciplines and areas in which he has discovered many new things. But now today we will focus on 5 discoveries. From many classes of numbers, he actually seen those properties in those numbers. One is called, one is called Kaprekar constant. Another is called Harshad number or Harshad Sankhya. The third class of numbers he discovered is, these are his names given to those classes. Dattatreya number or the Dattatreya Sankhya. Another is Kaprekar number. Most of the times, Kaprekar constant and Kaprekar number are treated as same, but friends, they are two different things. Kaprekar constant is one thing, Kaprekar number is another thing. That Kaprekar number is the name attributed to those class of numbers after Kaprekar dies. And the last one, and the most elegant, most astonishing, I must say, and intriguing, is his discovery of properties of self numbers and how to evaluate those properties. This self number or Swayambhu Sankhya, as he used to call it, and I am calling it Swayambhu Sankhya only because I will be using all the Indian names, only because once I say self numbers, one might think that it has originated from outside. But when I say Swayambhu Sankhya, the name itself declares that it has an Indian origin. So let me go first to Kaprekar constant by defining what is called Kaprekar subtraction. It is a special type of subtraction of numbers he first defined, and then he switched over to Kaprekar constant. That and maximum we start with integer obtained on arranging the digits of n in descending order. That is called n max. N minimum will be integer obtained on arranging the digits of n in ascending order. Then the subtraction of these two numbers, n max minus n minimum, is called kx. Not difficult to understand. Just I will have one illustration of 3-digit number. Consider a number 475. So when I arrange the digits in ascending order, I get n max as 754. Reverse it, I will get n minimum 457, and then its difference 297. So this is the special way of subtracting a numbers from any 3-digit number. If it is a 68, that is 2-digit number, he assigns 0 before that 68, make it a 3-digit number, and then define ks as 860, which is n max, minus 068 792. For single digit number, same thing, attach 2 zeros prior to 9 and subtract 900 minus 9 to receive the Kapreker subtraction value 891. I hope you understand it. Just arrange the number in ascending order first, descending order first, and then ascending order, and then subtract n max minus n minimum. For 4-digit number, same idea. If it is number 6642, maximum will be 6642 itself, already arranged in a ascending order, minus 2466 will give me 4176. Same for 202, I will attach a 0 before 202 at the highest place, and then subtraction 2200 minus 22 will give me 2178. Now with this definition for 3-digit and 4-digit, initially I am restricting myself to 3-digit and 4-digit. Kapreker move on to define for at most 4-digit number this subtraction again. When it is 7007 and 7000 minus 7, Kapreker move on to execute this particular subtraction algorithm on 3-digit number where all digits are not equal. Means we will avoid or exclude the digits like 333, where all digits are equal. We can understand that only because when all digits are equal, then Kapreker subtraction will have an answer 0. So he has excluded that. And then he defined first subtraction for 164. He repeatedly applied that subtraction technique to get the different numbers. So I have taken one example, 164. First subtraction, first level subtraction, I can say. Please unmute the audio if anybody has not unmuted it. I'm getting lots of sounds from your mic. Please unmute everybody.
I'll manage.
N is 164, then n max minus n minimum will be 641 minus 146, 494. He asks us to repeat the procedure now for 494. See what happens for 494. The same number 494 is again we receive. So for 495, subtraction is 954 minus 459, and answer is 495. Kapreker tells us that once the number starts repeating via such type of subtraction, that is my first Kapreker constant for 3-digit number. So for 3-digit number, Kapreker constant is 495. And this happens for all 3-digit number, for all 2-digit number, and for all 1-digit number. So next example, I will take 610, n max minus n minimum will be 594. Here it is not 495. So first cycle does not give me the required number. But when I apply same subtraction on 594, I will get 495. So I got the same constant 495 in 2 cycles. But For n equal to 7, if I repeat the procedure, first cycle gives me 693. Second cycle gives me 963 minus 369, 594. And then naturally third cycle will give me 495. Naturally a question arises, how many times one needs to repeat it? And the answer given by Kaprekar is maximum 6 cycles are necessary for any at most 3-digit number. The word at most indicates Praveen Kumarji, please unmute your mic. Maximum 6 cycles are necessary for any at most 3-digit number. By at most, I mean same thing again. It is either a 3-digit number or a 2-digit number, 0 backed by 0, or a single digit number 7, as we have seen, 007. So for all those numbers, conclusion is for all n in between 1 to 999, excluding the integers where all three are repeated, means 1, 1, 1, 2, 2, 2, etc. The Kaprekar constant is 495. You can check for all the numbers. Every time you will get the same number 495 on performing a defined a subtraction. Of course, 22 is allowed only because 022 is not a 3-digit number where all digits are equal. So we need to exclude only 9 numbers from the set of 999 3-digit numbers. And then for all 990 numbers, when I perform a Kaprekar subtraction repeatedly at the most 6 cycles, you will not require the 7th cycle to get 495. That is guaranteed. And I must say not guaranteed, it is proved that, I repeat what I am saying, it is proved that maximum number of cycles necessary are 6 for 3-digit number. Keep it in mind. We move to 4-digit number now. Same idea, same subtraction. First cycle gives me 6174 or 1274. 7421 minus 1274 gives me 6174. When I perform same operation on 6174, I get back 6174. So once a number 6174 starts repeating for such type of subtraction, and this 6174 is called 4-digit Kaprekar constant. If I start with 9834, I will require 4 cycles, as you can see on the screen. First cycle gives me 6354, second 3087, third 8352, and the fourth again 6174. In this case also, Kaprekar tells us that maximum 7 cycles are necessary for at most 4-digit number. Again here, those digits are excluded like 8888 only because first subtraction will be itself 0 and then nothing remains to repeat. So excluding 11112222 up to 9999, any number between 1 to 9999, when we apply a Kaprekar subtraction treating those numbers as 4-digit number by appending zeros when necessary, in at most 7 cycles, maximum number of cycles required 7, we will always get a number 6174. So this 6174 is called Kaprekar constant for 4-digit number. Now a natural question arises, can we prove it? Answer is yes, but it's a matter of time, it's a job in hand. Why I'm saying it is job in hand? Because if I start with any 3-digit number, say ABC, arranged in a descending order, my subtraction will be ABC minus CBA. That's fine. But from the latest or from the abstract number ABC and CBA and their subtraction to arrive at 495, which is a finite number, finite number, or for ABCD minus DABC, from an abstract number to arrive at a number 6174, it's a job. not that easy. I'm not saying it is very difficult, but I must confess that it is a difficult job to start from ABC or ABCD and to arrive at 495 via repeated subtraction. So it's like something unbelievable. How can we get 495 or 6174 from those abstract numbers? It's a job in hand. And I can confidently say that I have a proof of that. But it's not the time to go through the lengthy proof of those things. Let me move to Harshad number as Harshad. Harsha is Anand. So Harshad means a number which gives a joy. That's why it is called Harshad number. Definition is any natural number is a Harshad number if it is divisible by the sum of its digits. Not difficult to understand again. Consider any number, say 1 to 9. Sum of digits 1 to 9. They are divisible by them. So first case, all numbers from 1 to 9 are Harshad numbers. Second, I have a table before you. From 10 to 99, I have selected 5 numbers. 12, sum of digits is 3. 3 divides 12, so it is a Harshad number. For 18, sum of digits 9. Again, 18 is divisible by 9, so 18 is a Harshad number. But for 35, sum is 8. 35 is not divisible by 8. 35 is not a Harshad number. Same from 72, it is Harshad number. And for 91, sum is 10. So 91 is not an Harshad number. So for 2-digit number, Kaprikar defined Harshad number in such a way that if the number is divisible by sum of its digits, then it is called a Harshad number. For 3-digit, from 100 to 999, same idea works. For 102, sum is 3. Same for 285, 470, 629, and 879. If sum of the digits is divisible, sum of the digits divides the given number, then it is a Harshad number. A question, how many Harshad numbers are there in between 199? It is the answer. 180 Harshad number in between 100 and 999, and in between 10 to 99, the number is 48. Though it is not available on the screen. So 180 Harshad numbers are there. You can count. There are many interesting properties attached to this Harshad number, and they were discussed after Kaprikar. So Harshad number is one of the interesting numbers, have some special characters, and its properties were discussed by Kaprikar himself when he presented a paper. And then later on also, people work on some more properties of this Harshad number. Now let me move to what is called Dattatreya number. Dattatreya, as you know, is the name of the god, having 3 faces, Brahma, Vishnu, Mahesh, as we used to call it. So why the name Dattatreya is attached to those numbers is that particular triple has a particular property. That's the reason why it is called Dattatreya numbers. But it relates with the perfect square n square, not with n. So for a given n square, from n we will find n square and divide that n square into 2 parts, say a and b. If it is possible that that triple n square ab is a triple of perfect square number, means n square is already a perfect square number. If I can break up that n square into 2 parts in such a way that both a and b are also perfect square numbers, then that particular triple or set of 3 numbers, n square, a and b, that particular set is called or that n is called the Dattatreya number. If for that n it is possible for me to construct a triplet n square and parts of that a and b, all 3 perfect square numbers. Let us see what happens with example. split the digits of n in all possible ways. One example, 65 is square is 44 to 25. I can break up into three parts, 4 to 25, second 40 to 25, and the third 420 to 5. That is what he tells us as a breaking or dividing the given perfect square number into parts. Now observe that in addition to 4 to 25, a pair 4 and 225, both numbers are perfect square number. So we have a triple now, or set of three. First number is 4 to 25, second is 4, and third is 225. All three are perfect square numbers. So 65 is a Dattatreya number whose square, along with its one of the three possible parts, all three are perfect square numbers. If none of the part exists where both the numbers are perfect square number, then naturally there are numbers where such division or such breakup is not possible, then they are not Dattatreya numbers. For 34, say, square is 1156. Again, the parts are 1156. Second is 1156. 1 is a perfect square, but 156 is not. 1156, not perfect square. And 115 and 6, both are not perfect square. So we declare that 34 is not a Dattatreya number. For 325, say, this is an interesting case. That's why I have taken this example. The square is 105625. Now I can break it in many parts, but I consider a part 1 and 05625, one part. Remember, though there is a 0, but 5625 is a perfect square number. So we have a pair, three numbers. One is 105625, square of 325. Another is 1. And the third one is 5625. We must get at least one pair where all the three are perfect square numbers. Of course, here excluding 0, then 105625 is a Dattatreya number, and we need not find the remaining parts. So it's a matter of bit skill and observation. Can we break the given perfect square number in such a way that the two parts both are perfect square number? That's a skill part, of course. But again, I repeat, proof is available. For 721, 519841, it's a little bit difficult case because out of the possible parts, this part 51984 is a square of 288. But the students of Vedic mathematics can immediately observe and conclude that 51984 is a perfect square number. That's not difficult at all. And we can say that 519841 is a Dattatreya number. Now we move to the third one. I will bit little faster. Kaprekar numbers. As I called Kaprekar, constants are 495 and 6175. Yes, one more thing. Natural question is, what happens for 2-digit? No unique number exists. Subtraction does not yield. Every time you will get different subtraction. For 4-digit number, we have 6174. But for 5, 6, 7-digit number, unique numbers, unique answer is not possible. That gives series of numbers where the subtraction converges, not a unique number. Now I come to Kaprekar numbers. Consider any n-digit number. Then, as we know, n square will have at either 2n minus 1 parts or at most 2n digits. Then split that square into 2 parts. Again, here splitting is such that right part has n digits. So there is a restriction on the splitting that I must break up the number in 2 parts, left and right side, in such a way that right part should have n digits. Then naturally, left part will have either n minus 1 digits or n digits. Now observation and the proof again. If the sum of numbers in left and right parts equals n, remember what he is saying. Sum of the left and right part is equal to n, then such numbers are termed as Kapreker numbers. Let us have one example. For n square, n equal to 1, left part, right part, 0 and 1. Sum is 1. So 1 is a Kapreker, first Kapreker number, Kn as I marked it. What about 2 and 8? No such possibilities, because for 2, I will get 0 and 2. Its sum will be 2. And its square is 4, but sum is 2. Unequal. So up to 2 and 8, they are not Kapreker numbers. But for 9, say, square is 81. Right part must have 1 digit. So right part will have 1. Left part will have digit 8. 8 plus 1, 9. So sum is equal to 9. That's why 9 is the next Kapreker number. Consider 45 and its square. There is a 20, 25. Then two parts, 20 and 25. Its sum is 45. So 45 is the Kapreker number. For 70, square is 4900. Now right part will have 00, left part 49. Its sum is 49, which is not equal to 70. That's why 70 is not a Kapreker number. 703, same thing. Square is 494, 209. Right part will have 209, 3 digits equal to digits of n. 494 plus 209 will be 703. So 703 is a Kapreker number. Now come to 7777. Square is 60481729. Remember, its breaking will be again 6048 plus 1729. Answer is 777. Now I come to the last of my Kapreker discoveries, which is called self numbers. Regarding the Kapreker numbers also, a lot of study is available, a lot of research is available, a lot of Kapreker numbers properties are being studied and applied. You can go to internet, just type Kapreker numbers, you will get a lot of things to study. And you will also get a lot of avenues to have a research over the properties of all the numbers which we have already discussed. But one of the most elegant and most intriguing, most amazing discovery of Kapreker Sir is what he called Swayambhu numbers or Swayambhu Sankhya or self numbers. I must confess at the outset that it is slightly difficult to understand the concept of Swayambhu numbers itself, and then how Kapreker generates them, how Kapreker defined them. And again, you will find lot of applications of self numbers in mathematics, and not in mathematics, but in some applied areas also. Let us begin with the concept. Consider a sequence of number n, n1, n2, n3, n4, such that the second number n1 is obtained as sum of n plus sum of its digits, SOD. I am marking it. This is a notation of Kapreker again in his paper. So I just follow that notation. SOD means sum of digits of n. So what I will be doing to find the next number in the sequence, say n1, I will add to n its sum of digits. And the process is continued. n2, n1 plus sum of digits of n1, n3 plus sum of digits of n2, n2 plus sum of digits, so on. That is how sequence of numbers is created. Every next number is obtained by the sum of the previous number plus its sum of digits. Now a terminology. Kapreker says that if n1 is obtained in the defined way, then he calls it n generates n1. n1 generates n2. Because n3 is obtained obtained after adding n2 and its sum of digits, it is said that n2 generates n3, so on. But if I have any number who is not generated by any of the number less than itself, I repeat, not generated. What we have defined is one number generating another number. But if it is possible to find a number n which is not generated by any number less than itself, then Kaprekar termed such numbers as Swayambhu or self. Swayambhu means the number cannot be generated by any other number. That we used to God also we call Swayambhu, Swayambhu Shivam. That way also Kaprekar calls such number for which such generation is not possible for any number less than that number. So in mathematical terms, it can be said that n is a Swayambhu number if n is not equal to, I repeat, not equal to m plus SOD of m for any non-zero m less than n. Let us go to the test. How to test whether a given n is a Swayambhu number or not. In his one of the finest research paper, he has given the criteria for testing. Just I will read the criteria and then explain with illustrations. N is a self number if SOD of mod n minus dr minus 9i is not equal to dr star n plus 9i. All are his notations. I have not added anything. For all I up to 0 to d of n. Now what is dr star? Defined in two ways. If drn is even, then dr star n will be drn by 2. If odd, it will be drn plus 9 by 2. And what is drn? drn is equal to 9 if sum of digits mod 9 is 0. Number theory is coming in picture. And drn is equal to sum of digits mod 9 otherwise. And SOD is sum of digits and d of n is the number of digits in n. That is how Kaprekar puts whole idea in a one clumsy or slightly confusing, I will not say confusing, but intriguing manner in his research paper. So this test is given there. Now I try to simplify via illustrations this particular test so that we can have an algorithm to test whether given n is a self number or not. Again, I'm repeatedly saying that this self number has tremendous property, just like Bernoulli number, Archimedes number, Newton's number, so on. This self number is a very famous number, Swayambhu Sankhya, as we should call it, Swayambhu number. And it has many applications. Let us begin with a standard example. For two-digit number, we will begin. First step, find Bijanka, as we used to call it, digital root B of n for given n. Though the word Bijanka does not appear in the Kaprekar's notation, but something equivalent to mod 9 naturally tends to Bijanka of that digit. So I accept that notation, which is familiar to us. So find B. If B is even, then find n1, n minus b by 2. If B is odd, it will be n minus b plus 9 by 2. So first two steps. Third step, find n1 star, which is that generation, n1 plus SOD n1. And the test now, first test. If n is equal to n star 1, equal to, I repeat, if n is equal to n1 star, then n is not a Swayambhu number, because inequality gives the answer Swayambhu number. If it is equal, means it is a possible generation is possible. And we discontinue for two-digit n. If n is not equal to n1 star during my algorithm calculation, then there is possibility, I repeat, there is possibility that n is a Swayambhu number. Then how to confirm whether it is a Swayambhu number or not? The test, what Kaprekar says is, subtract 9 from that n2, find n2 star, same again, n2 plus SOD n2. Again, I will test whether n is equal to n2 or not. If n is equal to n2 star, then n is not a Swayambhu number. I am repeatedly saying equality tells that it is not a Swayambhu number. Inequality guarantees that it is a Swayambhu number. So for two-digit number, I have to perform these 4-5 steps, first test, and then a confirmative test. Let us have one example, so things will be more clear. Just same thing I have, just now we will start with the confirmative test this way. Now example, 22 say, 4 is the Bijanka or digital root, 4 is even, so I will subtract from n b by 2 to get n1, which is 20. Now I will find n1 star, means n1 plus sum of digits, so 20 plus 2, 2 plus 0 is 2, so 22. So I'm getting back 22. N is 22 and n1 star is 22. Apply the first test and declare that 22 is not a Swayambhu number. No need to go further. If n is not equal to n1 star, then go for confirmative test. Second example, 45. Bijanka is 9, which is odd number. So I will subtract b plus 9 by 2 from n to have 36. n1 star will be 36 plus 3 plus 6, 9, 45. Again, n is equal to n1 star. 45 is not a Swayambhu number. I have taken every time 2 examples so that we can understand the things more clearly. Now 31. Hopefully it is a Swayambhu number. Bijanka 4, it is even. So n minus b by 2 will give me 29. n1 star will be 29 plus 2 plus 9, 40. Inequality. N is not equal to n1 star, 31 and 40. So possibly 31 is maybe or may not be Swayambhu number, will be confirmed by the second test. Second test tells me that I should subtract 9 from n2. So it is 20, n1 minus 9. n2 is equal to n1 minus 9, not from n, but from n1. Then n2 star will be 20 plus 2, 22. Again, second test tells me that 31 is the given number and n2 star is 22, not equal. And it confirms that 31 is a Swayambhu number. I hope you are following what I am saying. Now 56. Bijanka 2, even number, subtract b by 2. 55 is the answer for n1. Then n1 star will give me 55 plus 5 plus 5, 65. Inequality, 56 and 65. So possibility that 56 may be a Swayambhu number. If I got equal in the first case itself, terminate the procedure, but not here at least. So for 56, I will subtract 9 from n1. So 55 minus 9. Remember to subtract 9 from n1, not from n. It is 46. n2 star, 46 plus 4 plus 6, 56 again. And equality, n is equal to n2. So even though I got in a first test inequality, second test tells me that n is equal to n2 star. So again, confirmative test fails. 56 is not a Swayambhu number. 255, I will just go on running it. First test fails. 255 may be a Swayambhu number. With Bijanka 3, I am subtracting b plus 9 by 2. Don't forget that difference. Bijanka odd and even. Second test tells me N2 minus 9 gives me 240. Added to N2, sum of digits gives me 246. Again, 255 is the given number. N2 star is 246. So inequality confirms that 255 may be a Swayambhu number. Why again maybe? Only because it is a three-digit number. So I have to run the same test one more times. For 2 digits, in 2 rounds, it is easy. But for 3 digits, I have to run the same test again. N3, now N2 minus 9. Then add sum of digits to N3. That gives me 237. Again, unequal. 255 given number, N3 star is 237. Inequality confirms that 255 is a Swayambhu number. So with this, I stop for today. Thanks a lot. I again thankful to all the authorities of university and department for inviting me to giving me a chance to tell something about Kaprekar discoveries. Remember, Kaprekar was a very senior and a very eminent mathematician, but very less known. I don't have any opportunity to meet him, even though I started my career, he was alive. But one of his disciples or ex-sahakari unke the, Mr. Ghodkhindikar from Nasik, Dr. Ghodkhindikar from Nasik. He is my friend. He was my friend, I must say. Unfortunately, he is no more now. Just 2 years back, he died. But he lives with Kaprekar. He used to travel with Kaprekar. And whenever we meet in some conferences or in some meetings, he was a Karyakarta of Vidya Bharati and our Nyas also. So he used to attend those conferences or meetings or baitaks frequently from Nasik, but he is not no more. He told me once a time, whenever we meet, one topic is always a Kaprekar. How Kaprekar works, what was Kaprekar was thinking. And he has written 2 or 3 books on Kaprekar, one in Marathi, one in English, and possibly in Gujarati also translated too. So a lot of literature is available on Kaprekar. So I dedicate this talk to the memory of Kaprekar Sir as well as his disciple and my good friend Ghodkhindikar Sir. He has done a lot to enlighten the works of Kaprekar to all of us. So thank you again. Namo Namaha. Now I open my platform to any query, any comment, any suggestion, anything you want to know. I request organizers to open it and escape the shit.
Thank you so much, sir.
Thank you.
All the participants are requested to ask any query.
Yes, ma'am. Myself, H.N. Singh. Myself, H.N. Singh.
Yes, yes, sir. Yes, sir.
Sir, in Kaprekar subtraction,
Yes.
from numerology point of view,
Yes.
for 3 digit, 4 digit, the sum comes out to be 9. So, क्या 5 digit, 6 digits के लिए भी इनका sum 9 होगा?
For 4, as I said, for 4 digits, more than 4 digits. And from numerology point of view, I have not tested. But if you're saying that the, I hope you are saying about the Bijanka.
Right, sir. 495, sum comes out to be 9. 18,
yes,
8 plus 1, 9. And
yes.
6174 also again comes out to be 9.
Comes out to be 9.
So,
but that doesn't happen with the 5-digit number. ओनली बिकॉज इसलिए ऐसा नहीं होता है कि जब हम 5 डिजिट पे उस प्रकार का सब्ट्रैक्शन अप्लाई करके देखते हैं तो एक यूनिक नंबर नहीं आता है. वी गेट string of numbers. So there are 4, 5, 6 numbers where that subtraction terminates. It is not a unique number.
Right, sir. Right. Thank you so much, sir.
Thank you.
Thank you, Achan Singh sir. Any other query from others? About Capricorn number, जो भी सर ने बताया उसके रिगार्डिंग अगर किसी को कोई क्वेरी है तो आप पूछ सकते हैं.
How you feel that? At least that much you can say.
Yes.
I was always excited with Capricorn.
Yes, of course. Definitely बहुत इंटरेस्टिंग मतलब रहा लेक्चर. काप्रेकर थ्योरी अभी तक पता भी नहीं है लोगों को, काप्रेकर जी का नाम भी नहीं सुना है.
That is the sad part of it. One incident I may quote now because you are saying that sabhi ko pata nahi hai. Borkendike sir was visiting America. He has traveled a lot of countries, and once upon a time he was in a Nokia mobile headquarters for giving some discussion on numbers. And as soon as he starts saying that, he used to say me always this incident. जब भी मैं वहां पे गया और जैसा ही मैंने कहा कि मैं उस देश से आया हूं जहां पे काप्रेकर का जन्म हुआ और मैं काप्रेकर को जानता था और काप्रेकर इज माय गुरु, immediately everybody in the audience stood up in the respect of Capricorn, and the chairperson of that particular date was said that we not sit when we listen to name of Capricorn. We respect Capricorn. He was a chairperson of Nokia mobile number company. He knows Capricorn and his work. So there must be, I suspect, I am not sure, it's just a, you can say, imagination, that there is some relation between the mobile numbers which we used to do apply every day and some of the discoveries with Capricorn numbers. Some of the discoveries of Capricorn number, but Nokia will not reveal it. Let us see, future may give some idea sometimes.
Definitely, sir. तो काप्रेकर जी का इतना काम है जो आपने बताया, तो मतलब इसको जान के अच्छा लग रहा है, सम्माननीय है हमारे लिए. और किसी को कोई क्वेरी हो तो हम उसको आमंत्रित करते हैं. हमारे साथ में शिक्षा संस्कृति उत्थान न्यास से वीरेंद्र कुमार तिवारी जी जुड़े हुए हैं. मैं आमंत्रित करना चाहूंगी भाई साहब को.
यस,
जी जी,
नमस्ते भाई साहब.
नमस्कार जी, सभी को प्रणाम.
हाँ, बोलिए बोलिए.
जी जी, अपने विचार रखिए भाई साहब.
आपका आयोजन बहुत अच्छा रहा. बहुत भाई साहब का जो लेक्चर था बहुत ही यूजफुल था, बहुत ही इंटरेस्टिंग था, बहुत अच्छा लगा. इनके सामने कुछ बोलने का मतलब नहीं है हम लोगों को.
थैंक यू.
धन्यवाद धन्यवाद भाई. ठीक है, मैं आमंत्रित करना चाहूंगी डॉक्टर योगेश चंदना जी को, जो हमारे बीच में आज इस पूरे सेशन को चेयर कर रहे हैं. तो वो वोट ऑफ थैंक्स के लिए आ रहे हैं. थैंक यू.
उसके पहले I may request Dr. Padmaja from Tamil Nadu here. She has joined and she will like to say something. Dr. Padmaja, please. He is also one of our कार्यकर्ता.
सर आप बिल्कुल आमंत्रित कर सकते हैं क्योंकि मैं सबको नहीं जानती हूँ.
हाँ, मैं बहुत लोग जानता हूँ, मैं बहुत जानता हूँ, बहुत सारे लोगों को जानता हूँ.
तो सर अगर कोई और भी हमारे बीच में ऐसा,
डॉक्टर SV Padmaja, please unmute you.
Please unmute your mic, ma'am.
It's me.
Yes. You can switch on your video also.
Yes, sir. Yes. Yes, sir. Namaste.
Yes.
Sir.
Namaste. Namaste.
Nice to talk with you.
Yes.
Sir, your lecture is very nice. Capricorn, I am also very interested to learn that numbers. Already we know, but in your speech, I get so much clarity. Once again, I am SV Padmaja. I am student of ShriRam Chauthaiwale Sir.
Yes.
From Bangalore. Yes.
Yes.
Thank you.
Thank you for connecting with us, ma'am, from the
Yes.
department of CCS University.
Yes.
Sir, any other guests from your side? Please invite him or her.
Devraj is there.
Yeah.
Devraj ji, anything you want to say?
Nidhi madam is also here.
Yes, Nidhi madam
I
is
would
there.
like to invite Nidhi and madam from Gurukul Kangadi University. Ma'am, please say your kind words.
Namaste, madam.
नमस्कार सर। आपका बड़ी, आप तो कहीं नई नई चीजें ढूंढ के लाते हैं, तो इसका रेफरेंस जो है मैं भी आपसे लेना चाहूंगी और कुछ सीखना चाहूंगी, क्योंकि वाकई में इतना बड़ा कोश है अभी भी जो कि अनफाउंड है और उसको हमें ढूंढना है, उसके लिए कुछ काम करने हैं। तो सर आपका ये लेक्चर जो है बहुत मालूमाती था और बहुत कुछ जो है इसमें आपसे भी सीखना है और खुद भी स्टूडेंट्स जो हैं एनकरेज जरूर हुए होंगे आज कि हम इन चीजों की तह पे जाएं और इसको स्टडी करें अच्छी तरह से। तो सर आपको आपके इस सुंदर व्याख्यान के लिए, जिसने कि हम सब की नॉलेज को और प्रकाशित भी किया है, मैंने भी अपने लाइब्रेरी में एक ये कैप्शन और ऐड कर दिया है। तो सर इसके लिए बहुत बहुत धन्यवाद है। और जो स्टूडेंट्स हैं वो एनकरेजमेंट आपसे लेंगे। आपके इस लेक्चर के लिए हमने जो है बहुत सारी जानकारी हमें पता चली। थैंक यू सर।
Thank you. Dr. Rajesh Thakur is on the screen, please. Dr. Rajesh Thakur ji. If Vipul Sharma ji want to speak, he can.
सर बहुत ही अच्छा सेशन था, बहुत अच्छी अच्छी जानकारी आपसे मिली।
Actually, sir, he is sitting in a hall, so
Okay,
that's why
okay,
his voice is echoing.
okay. Anybody on who has joined online, anybody can switch on his mic and say something. If otherwise, we will conclude. Time is already over.
Yes. I think, sir, we should conclude this session.
Yes,
Sir?
Patankar sir was there in the
Okay. Sunil
Sir,
Patankar
Sunil
Sir.
ji.
ji.
Madam, 1 minute.
Okay, Padmaja ma'am. Ji.
Yes.
Sir, tomorrow which topic you are going to start? Tomorrow section is there?
Ma'am, I'll send all the title of the talk in the group. If you are you are in the group or not? I think so. Next topic: applications of Vedic sutras and sub-sutras from Dr. Rakesh Bhatia sir for the coming next session.
Okay, ma'am. Sorry,
Yeah,
I
for the
think
next
I'm not having in group. Once again, I'll request to add my number to sir.
Okay.
Thank you, sir.
So I would like to invite Dr. Yogesh Chandana sir to conclude the session for paying the vote of thanks for ShriRam Chauthaiwale Sir session. Sir, please come.
Good afternoon, everyone. We are blessed, sir. We are totally blessed with your eye-opening session. And I think most of us might not be knowing about Kaprekar constant, Kaprekar numbers, Dattatreya numbers. Yes. So it was really an eye-opening session, and I would like to express my gratitude on the behalf of Department of Mathematics, CCS University. Sir, Shivraj sir, please. Okay. So thank you for all your support, and none of our initiatives would have been possible without your support. So thank you very much once again for your continued support. Thank you very much, sir.
Thank
A
you.
man of honors. Yes. Thank you very much.
मैं सभी के लिए बताना चाहूंगी कि अभी हम लोग एक लंच ब्रेक के लिए रुकेंगे और आफ्टर लंच ब्रेक वी विल मीट जॉइन अगेन एट 2 PM.
डॉक्टर
या शिवराज सर प्लीज.
जस्ट ए मिनट, मेरी आवाज आ रही है डॉक्टर सुनील?
यस सर आ रही है.
है ना, जैसे डॉक्टर सरू ने कहा था कि वर्चुअल लंच के लिए भी सबको अप्लाई वो कर दीजिए, इनवाइट ऑनलाइन मेंबर्स को भी.
थैंक यू सर, थैंक यू सो मच.
थैंक यू फॉर
थैंक यू श्रीराम सर. और आपके बहुत सारे लंच, डिनर और ब्रेकफास्ट पेंडिंग है मेरठ में.
ठीक है सर, जल्दी हो जाएगा.
हाँ हाँ, और बहुत इंफॉर्मेटिव था. मैं थोड़ा सा बाहर हूँ लेकिन मैं सुनता रहा हूँ लगातार इसे. तो थैंक्स अ लॉट सर. ये सेंटर आप ही की वजह से, आप लोगों की वजह से.
सर मैं ये भी बताना चाहूंगी कि मैं अभी देख नहीं पा रही थी कि सर ज्वाइंट है नहीं ज्वाइंट है, अदरवाइज सर को मैंने बोला था कि जब सर बोले. जी थैंक यू सर. शिवराज सर.
थैंक यू. ठीक है डॉक्टर सोनिया, प्लीज कंटिन्यू.
जी जी तो ठीक है, हम लोग फिर मिलते हैं. और जैसा कि अभी सर ने बोला कि आप सभी लोग इनवाइटेड हैं, मे बी वर्चुअल और लाइव लंच. तो हम लोग फिर से मिलते हैं 2 बजे.
थैंक यू.
थैंक यू ऑल.